Okay, how we doing, guys? All right, so here is the last part for our energy systems. We're going to finish up with the aerobic energy system. So let's go ahead and jump into this. It'll be really quick. It's just a nice, the final add-on piece for the three energy systems that we have been talking about for the past couple of weeks. So your last one is your aerobic energy system, which is also referred to as your diesel energy system. And I'll explain why that is. One being that it is a slow and steady type of energy system. Um, it burns your energy way slower than the other two. It also requires less effort really to activate it. This isn't something that's going to have a high energy output. You're really looking at going at more of a slower pace in order to sustain this sustain activity in this energy system as well. The next part of it, very low, there we go. It actually uses carbs, fats, and sometimes proteins. Now, it's important that you do have it in this order because this is actually the order that this energy system decides to burn up these particular fuels for energy. So it's going to burn up your carbs first, your carbohydrates, and then eventually, once those are depleted, it'll move on to your fats. Now, your carbohydrates are going to be things again like pasta, bread, and things, things of that nature. The fats are going to be the fatty composites that you have in your body, as well as the empty calories that are left over from the foods that you eat. Now, the last piece of this is gonna be the proteins. Now, the proteins are going to end up being burned off. A good way to look at this is your proteins are essentially like comparing a football player to a marathon runner. You'll notice that the football player, yes, does have some aerobic exercises that they will partake in, but they don't do enough to where it actually takes away from their muscle mass. Whereas you look at a marathon runner, the marathon runner is actually going to be constantly in that aerobic energy system. So they're constantly burning away those proteins, which is what gives you the smaller frame on them. Now, this does have a limitless capacity. The big difference between your aerobic energy system and your ATP and your anaerobic energy systems is that this one's actually capable of increasing the length of time that you can be in this energy system. That is the one main difference from it. There is no limit to how long it'll last. Once you enter into that energy system, it will last as long as you are able to maintain it. And kind of piggybacking off of that, it does kick in at that 3 minute moment. So, right at the end of your anaerobic energy system, you start going into your aerobic energy system. And like I said, it goes as long as you can possibly maintain it. So, if you wanted to train to be able to run at a certain pace for 10 or 15 minutes, you can do that. The aerobic energy system will allow you to do that. Just the same, if you wanted to be able to run a marathon in 3 hours, and right now you can only run for 20 minutes. Well, you can train yourself to be able to do that, and the aerobic energy system is going to allow you to do so. And the last part is what with having that limitless capacity, the one caveat is you are more prone to feel lactic acid buildup. Now, lactic acid buildup is nothing more than that cramp you may get when you've been outside playing for a long time and running around, and then you stop moving and you feel like your sides start to cramp up or your legs start to get tight or something like that. That is lactic acid building up in your body. Now, essentially, how lactic acid works, you actually do build lactic acid when you're performing ATP movements as well as anaerobic movements. The difference is that those movements happen so quick, and the lactic acid is actually being broken down as it is building in your body because you are moving to break it down. So the more you move and the quicker you move, the faster it is able to break down. Versus your aerobic energy system, where that lactic acid is slowly being built up, but because you're not moving as fast and you're not as explosive, it's not being broken down as fast. So when you do stop moving, you do have some residual leftover lactic acid that does cause the cramping and tightness in your body, which is another reason why, if you've ever been working out or doing anything like that, you'll hear from your coach or someone that say, to keep moving, to stretch, do something to keep the blood flowing through your body pretty regularly, because once you stop, the lactic acid stops moving. And wherever it happens to stop, that's usually where you get your cramps and your tightness and everything like that. And a prime example of an aerobic activity essentially is going to be distance running, marathon running, anything like that. But it is not limited to just that. Um, it essentially can be anything that goes into that past that 3 minute threshold. So if you decide you want to jump rope for 10 minutes straight, you are now doing an aerobic exercise. If you decided you want to swim 4 or 5 laps in a pool and that takes you 12 minutes, you are doing an aerobic exercise. So it's not, stuck to just distance running. It can be anything as long as it's a physical activity and it steps into that threshold.